Hi, we're going to learn how to solve this acceleration problem. We're going to do it two different ways. First way, we're going to use my 6 steps. We'll use my 6 steps for the second way, is just different units. So my first step is, what am I looking for? And I know that I'm looking for, what was the acceleration? So I know the formula for acceleration is A equals. And looking back in my notes, my formula for acceleration in step 2, what is my formula? Is speed final minus speed initial divided by time. So this is where it gets tricky. We have two different speeds, 60 miles an hour, 50 miles an hour, and a time. So let's take care of the time right off the bat. That's the easy one. The hard one is we have this minus sign here, which means we have a final speed and an initial speed, and we subtract them. So we have to determine which one's first and which one's second, which is final and which is initial. Well, our question tells us that we're slowing, which tells us our final speed is going to be smaller than our initial speed. So now I know it's 50 miles per hour, and I'm writing out my units, minus 60 miles per hour. Now I know step 4 after we've plugged in our numbers with step 3, step 4 says check our units. I'm going to do this right off the bat. Our units are good here, so this ends up being a negative 10 miles per hour because our 60 is bigger than our 50, so we're going to end up with a negative 10 over 2.6 seconds. Now here's where it gets tricky. This can't stay this way because miles per hour per second is not an acceptable unit for acceleration. We have to do miles per hour or feet per second per second. So let's convert this to hours. And looking at our previous notes, we can use our conversion formula where hour or seconds, we take seconds, 2.6 seconds, and we divide that by 3,600 seconds per hour. And our units are going to cancel. We end up with hours. And this ends up being in our calculator a little funky. It looks like 7.2 times 10 to the minus 4, which is telling us that this decimal place has to move 4 times. 1, 2, 3, 4. We'll put our decimal in and fill our places in with zeros because that's what belongs there. So this number, 2.6 seconds, actually becomes 0.0007 hours. And once we do the math here, now our units works miles per hour, which is an acceptable unit for acceleration. We end up with a negative 14285 miles per hour squared, or miles per hour. That's a really weird number, so let's look at this another way. I'm going to start out with, what am I looking for again? So I'm looking for acceleration. Acceleration equals, we know our formula is speed final minus speed initial over time. So again, we need to determine whether or not we're speeding up or slowing down. Our question tells us to slow down. So we're going to go with 50 miles per hour because that is our final speed, minus 60 miles per hour over our same 2.6 seconds. So this looks exactly the same as we did before. We're going to continue with this. This is going to be a negative 10 miles per hour over 2.6 seconds. We end up with the same exact problem we had before with incorrect units. So we're going to convert, this time we're converting our miles per hour to feet per second. So we have to look back at our conversion sheet, and you can do that from a previous set of notes. We're going to convert miles per hour to feet per second, and we know we take miles per hour times 1.47, which is our conversion factor to get it to feet per second. So we know this number now is going to change to 14.7 feet, that's feet per second, over 2.6 seconds. Because remember, that's converting, this is converting this to feet per second. So when I do that math, I end up with a number, it's 5.65 feet per second squared. Remember, it's feet per second. And that's a second way of doing that problem. And that number looks a little bit more manageable than the number we had before that was 14,285. Hope this helps.